Bright Duty. Every student matters.
Hello everyone. So now we are going to discuss questions on prime factorization. So let's get started, and we have questions on divisibility rules as well. So here is the first question where we have to tell the statements are true. Okay, which of the following statements are true? So let's discuss one by one all of them. The first one is, if a number is divisible by 3. What are they saying? If there is a number which is divisible by 3, it must be divisible by 9. Can you think about it? Is it always going to happen when a number is divisible by 3, it must be divisible by 9. Okay. What do you think about 21? Is it divisible by 3? Yes. But is it divisible by 9? No. So this statement is false. Clear? The second statement is, if a number is divisible by 9, then it must be divisible by 3. Yes, because 9 is what? 3 into 3. So if a number is there which is getting divided with 9, which is divisible by 9, so yes, it will be divisible by 3. So this statement is true. The third statement says a number is divisible by 18 if it is divisible by both 3 and 6. So what are they saying? A number is divisible by 18 if it is divisible by both 3 and 6. So you can take up one example. Suppose I take 30. Is it divisible by 3? Yes. Is it divisible by 6? Yes. Is it divisible by 18? No. So this statement is false. The next statement is, if a number is divisible by 9 and 10 both, okay, there is a number which is getting divided with 9 and 10 both, then it must be divisible by 90. 9 into 10 is 90. If the number is getting divided with 9 and 10, then yes, it will be divisible by 90. This is true. Also, here you could see 3 and 6, they are not co-primes. Okay, 9 and 10 are co-primes. So the number would be divisible by the product as well. The next question is, or the statement is, if two numbers are co-primes, at least one of them must be prime. Is it always true? No. Can you think of an example where two numbers are co-prime and both of them are composite numbers, none of them is a prime number? Yes, there are many examples, just like 15 and 32. You know, so in this other than 1, we will not have any common factor. So they are co-prime number. When you check out of all the factors, there will be only one factor common, that is 1. So these are co-primes, but these, you can see, both of them are composite numbers. So it is not necessary that at least one of them must be prime. So this is a false statement. Next is F part, which says all numbers which are divisible by 8 must also be, all the numbers which are divisible by 4 must also be divisible by 8. Is it always true? The number which are always getting divisible by 4, they will be divisible by 8. So you can take an example of 12. Okay, it is divisible with 4 but not divisible with 8, right? So this is false. The next is, all numbers which are divisible by 8 must also be divisible by 4. 8 is what? 4 into 2 is 8. So we can say that it will be divisible by 4 as well as with 2. Okay, by all of its factors. So 4 and 2, yes, they are factors of 8. It will also be divisible with 4. This is a true statement. The next statement is, if a number exactly divides two numbers separately, there is a number which exactly divides two numbers separately. Let us take 2. Okay, it is dividing 4, it is dividing 8 separately. It must exactly divide their sum. 4 plus 8 is 12. Is it dividing their sum exactly? Yes. So this is true. If there is a number which is exactly dividing two numbers separately, 2 divides 4, 2 divides 8. Okay, separately it is dividing. It must also divide their Sum exactly. So yes, 12 is the sum and it is exactly dividing. You can take up other examples, so you will get the same answer. So this is going to be a true statement. The last statement, if a number exactly divides the sum of two numbers. Suppose we take 2, 2 is dividing 12. That is 12 is the sum of two numbers. It must exactly divide the two numbers. You know 12 we can get from 7 and 5 also. Is 2 dividing 7 and 5? No, none of them. So it is a false statement. Clear? Moving to the next question, as you can see here we are given different factor trees for 60. We have to write the missing number. What we did in the factor tree, we were writing all the prime numbers and at the end we were able to express a number as the product of prime numbers. So we are going to just write prime numbers. Here what they have expressed that 60 can be written as 6 into 10. Okay, now 6 can be written as 2 into 3. Think about the prime number. 2 is prime, 3 is prime. Then 10 can be written as 5 into 2. Done this one. The next one is also the factor tree of 60 only. Now see, here it is 60. 60 can also be written as 30 into 2. Right? 30 into 2 is 60. Now 30 can be broken down to 10 into 3. Okay, 10 into 3 is 30. Now 10 can be broken down. See, 3 and 2, these are prime numbers. Will not, further be doing anything with them. We have 10 here. Can we convert 10 as the product of two prime numbers? Yes. We can write that as 5 into 2. So what do you see at last? 2, 3, 5, 2. So yes, 2 is coming 2 times, 5 one time and 3 one time. So answer is exactly same whichever way you do it. Right? So this is how we write the missing numbers in the factor trees. So the next question is here now. It is asking what factors are not included in the prime factorization of a composite number. Let us first take a composite number for an example. Suppose I take 18. Do the prime factorization. The smallest prime number is 2. So 2 nines are 18. Then you will do with 3. 3 threes are 9. So how do you write the prime factorization of 18? 18 can be expressed as the product of prime factors. 2 into 3 into 3. So what are you not including? We are not including 18 and the number itself, that means 18 and 1. Okay, so which factors are not included? The factors of 18, when you try, you write 1 into 18, then 2 into 9, then 3 into 6. Okay, and then what do we have after 3 into 6? We have 9 into 2. Okay, so 9 is already there, so we will stop here. So these are all the factors. So actually 3 into 3 is 9, so basically 9 is included indirectly. 6 is there, 2 into 3 becomes 6. What we are not writing, actually we are not writing 1 and 18 here. So in the prime factorization, what is not included or what factors are not included? 1 and number itself we do not include. Clear? Actually this gives you 18 only, but when they say that what factors are not included in the prime factorization, we do not include 1 and the number itself, because if you include 18 also, okay, so this will not stay as prime factors. 2, 3 and 3, they are prime factors. We are expressing the number as the product of prime factors. If I write 18, 18 is not a prime number, right? So that's why we just include the prime factors, that is 2, 3 and 3 in this case. So we do not include 1 and the number itself, because the number can be composite, right? Okay, moving ahead, there is another question. We have to write the greatest 4-digit number. Can everybody write the greatest 4-digit number? Yes. So how do we form the greatest 4-digit number? The greatest digit is 9. So we will write it 4 times to form the greatest 4-digit number. Now we have to express it in terms of prime factors. Okay. So how do we do it? We can do it using the factor tree. We can write that, or we can also do it just by the same method that we do for other questions. So first of all, do you think with which number it is going to get divided? The first prime number that will divide it is 3. So 3 threes are 9, 3 threes are 9. We will get 4 times 3. Now after it, when I divide again with 3, we will get 4 times 1. Okay. So now with 11, okay. So 11 ones are 11, then 0 will come and 11 ones are 11. So this we will get. Now again we have 101. So that's a prime number will not get divided. So what are the prime factors? 9,999, which is a greatest four-digit number. Its prime factors are 3 into 3 into 11 into 101. So this would be your answer. Clear? Let's do the next question. Where is the next question? It is asking, write the smallest five-digit number. So how do we form the smallest five-digit number? We see the smallest digit is 0. So we'll start with 1, which is the next digit just after 0. So, and you add 4 zeros to it. Yes, so this is the smallest five-digit number. Now, to express it in the form of its prime factors, let's start dividing it. So first of all, we will write with 2. So just see, we'll start with 2, we'll divide it with 2 like this, 2 fives are 10. Okay, then you will copy down the zeros. Then again with 2, 2 twos are 4, 2 fives are 10, then 0. Again with 2, okay, so 2 ones are 2, 2 twos are 4, 2 fives are 10 and 0. Then again with 2 we will divide, 2 sixes are 12, 2 twos are 4, 2 fives are 10. Now with the 2 it is not possible to divide it. With 3 also it will not get divided. So we will divide with 5 then. So 5 ones are 5, 5 twos are 10, 5 fives are 25. Again you divide it with 5, 5 twos are 10 and 5 fives are 25. Then again you divide it like this and here we finish. We get 1 at the end. So this can be written as, see how many times 2 we have, 1, 2, 3, 4, 4 times 2. So 2 into 2 into 2 into 2 and 5 is coming also 4 times. So 5 into 5 into 5 into 5. So it's prime factors in which 10,000 can be expressed. Okay, that is 2 and 5. Moving to the next question now. It is asking you to find all the prime factors of 1729. So first we will do the prime factorization of 1729 and after that we have to arrange them in ascending order. This is the second thing to be done in the question. First is to find the prime factors of this. Second is to arrange them in the ascending order, and then they're asking we have to state the relation, if any, between the two consecutive prime numbers. So whatever prime numbers we will get between them, we have to state the relation. Okay, so 1729, when we start dividing with 2 and 3, it will not be getting divided with 5 also. 7 will divide this. So we basically will get 247 dividing it. So then we will divide with 13. So we'll get 19 and like this. So we get 1729 as product of 7, 13 and 19. Are they arranged in ascending order? Yes, because we started with the smallest one. And now we have to state the relationship between the consecutive. So let us just see these. If I find the difference of 13 and 7, you see it is 6, and you find the difference of 19 and 13, that is also 6. So what is the relationship? That the difference between any two consecutive factor is 6. So this is the relationship. These are the prime factors and we have arranged them in the ascending order. So this is what the question was demanding for. Let us now move to the next one. The next question says, the product of three consecutive numbers is always divisible by 6. Okay, what is the statement? That when you multiply any three consecutive numbers, it will always be divisible by 6. So they're asking, can you verify the statement with the help of example? Yes, easily we will try to take some consecutive numbers and three consecutive numbers. So suppose I take 2, 3 and 4. Let's multiply. 2 into 3 is 6, 6 into 4 is 24. Yes, 24 will definitely be divisible by 6. Let's take some other example. Let's take 5, 6 and 7. So 5 into 6 is 30, 30 into 7 is 210. Will this be divided with 6? Definitely. See, 6 threes are 18 will come up. Then if you subtract that, then what are you going to get? 3. And copy down 0. So 6 5s are 30. So see, it is exactly divisible. So yes, we have verified the statement which is written in the question that if we take any three consecutive numbers, their product will always be divisible with 6. Going to the next question now. Here is this. It is saying that sum of two consecutive odd numbers. Okay, we have to take up odd numbers and they should be consecutive. That means one after the another. We have to take their sum and they're saying it is divisible with 4. So you have to verify this statement with the help of some example. As we discussed in the previous question, it is of the same type. So let's take odd numbers. If I start with 1, I take 1 and 3. The sum is 4. Yes, it is divisible with 4. Let's try some different odd numbers and they should be consecutive. 3, after 3 the odd number is 5 only. So 3 and 5 is 8. Yes, it is divisible with 4. If I take 5 and 7, yes, these are consecutive odd numbers and the answer is 12 for their sum. Is it divisible with 4? Yes. So we can take some other numbers, like if I take 11 and the next odd number after 11 is 13. So what do we get is 24. Okay. Is it divisible with 4? Yes. So we have taken certain examples of consecutive two odd numbers taking out their sum and it is showing that it is divisible by 4. Going to the next question now. Okay, they're asking in which of the following expressions prime factorization has been done. There are four parts given to us. We have to identify in which expression prime factorization is been done. Let's just figure out. So going with the first part of the question, that is A part, where we have written 24 as 2 into 3 into 4. What do you think about 4? Is it a prime number? No, this is a composite number. So here prime factorization has not been done. Then we have 56 as 7 into 2 into 2 into 2. 7 and 2, there are two numbers in the prime factors factorization. So are both of them prime factors? Yes. So here we have done the prime factorization. Prime factorization has been done here. The next is 70, that can be written as 2 into 5 into 7. Are all these three numbers prime? Yes, they are prime. So here also it is done. Then we have 2 into 3 into 9. What do you think about 9? It is not a prime number. It is a composite number. So here prime factorization is not done. Clear? Then the next question is, determine if 25,110 is divisible by 45. They have given you a hint also that if 5 and 9 are co-prime numbers, then we have to test the divisibility by 5 and 9. Yes, we have this property. If there is a number which is divided with two different numbers and the numbers are co-prime, then yes, the number gets divided with the product also. So we see that 45 is can be written as 5 into 9, and 5 and 9 both are co-prime. Co-prime means if I take the factors of 5, that is 1 and 5. If I take the factors of 9, that is 1, 3, 9. Okay, do you see any factor common other than 1? No. So these are co-primes. Okay, if there is a number which is divisible with two other numbers and they are co-prime, that would be divisible with their product. So if I check the divisibility of 5 and 9 with this number, I can say it will be divisible with 45 as well. So first of all, checking the divisibility of 5, 25,110 ends with the digit 0. Divisibility rule of 5 says that if you have 0 or 5 as the end digit, okay, so it is ending with digit 0. So it is divisible with 5. So one divisibility test is done. Okay, the next is 9. What is the divisibility rule for 9? You have to add the digits. So add the digits to 5 plus 1 plus 1 plus 0. What is the sum that we are getting? 5 plus 2 is 7, 7 plus 1 8, 8 plus 1 9. So we get 9 plus 0, that is 9 only. So yes, 9 is divisible with 9. So this number is basically divisible with 5 as well as with 9. Hence you will write that it will also be divisible with 45. Okay. Take care that the numbers which you are taking 5 and 9, they should be co-prime. Clear? This is how you do these questions. And the next one, okay, in this question they are saying 18 is divisible by 2 and 3, both of the numbers, okay. It is also divisible with the product of 2 and 3 because you see 2 and 3 are co-prime, only one is the common factor. So yes, it definitely will be divisible with their product. Now they are saying similarly a number is divisible by 4 and 6. Can we say that the number must also be divisible by 4 into 6? If you say no, give an example to justify the answer. Okay, so if a number is divisible with 4 and 6 and it is can we say that the number will also be divisible with 24? Okay, so let's take one example. So we see that 4 and 6 are not co-prime. They have one more factor, that is 2 as a common factor other than 1. So yes, they are not co-primes. We are quite sure that the product will not be, getting divide the same number. So what example I can take is suppose 12. Okay, is 12 divisible with 4? Yes. Is 12 divisible with 6? Yes. Now what about 24? Will it get divisible with 24? No. Let's take 36. Okay. Is 36 is the number that is divisible with 4? Yes, it is divisible with 4. You divide 36 with 6. Is it exactly divisible? Yes. But what about 24? Will 24 divide 36? No, it will not divide 36. So we have given two examples to verify this answer, right? That it will not be divided with 24 because 4 and 6 are not co-primes. This happens only with the numbers which are co-primes. Next question. They are saying I am the smallest number having 4 different prime factors. Can you find me? So it is saying that it is the smallest number. I am the smallest number and I have 4 different prime factors. Okay, it is not like 2 into 2 into 3 into 3, that 2 are same and 2 are different. No, it should be all 4 different prime factors. So how we can find it? Let's just figure it out. Because students, this is the smallest number, so it will definitely be formed with the different prime factors but smallest prime factors. So the smallest 4 prime factors are 2, 3, 5 and 7. These are the first 4 prime factors. If you multiply them, you will get your number. Okay, why are we taking these numbers? Because this is the smallest number and all the prime factors are different. So all the smallest prime factors will be in this one. So let us just multiply it. 2 into 3 is 6. 6 into 5 is 30 and 30 into 7 is 210. So this is the smallest number. Okay, when you do the prime factorization, you will get these. That means all the 4 numbers are different, they are prime. So the number is 210. Clear?